Good morning. To all my students, today in this video, I want to introduce application of combinatorics and binomial theory. Application of combinatorics and binomial theory in probability. To do the sums probability questions, to do the sums of probability, you have to learn binomial theory and combinatorics, sets and relations. These three are very important topics: sets and relations, binomial theory, permutations and combinations, that is called combinatorics. These topics are very important for every student when he wants to do probability questions. Today, the involvement of applications of combinatorics and binomial theory, the involvement of them in probability, you are going to learn. Before learning this, you have to know, share my videos, subscribe my videos, and click the bell icon so that my videos are updated, so that you will learn more better things in the important topics related to IIT, JEE, automatically related to MSET and other competitive exams. Other competitive exams may be other deemed universities conducting exams, just like BITS, Piloni, like that. For all competitive exams, it will be more helpful. First of all, you have to do this. Subscribe and click the bell icon and get all my videos updated. Coming to the subject, some basics in combinatorics I discussed. Some basics in combinatorics I discussed. That is, in this video, please go through all the basics I have written and explained in this video. Permutations and combinations, some basics, and relation between permutation and combination. I have also given it. And at the same time, division of identical objects into groups. Division of identical objects into groups. This notion is more useful, more applicable in so many cases of difficult questions while solving them. In connection with this, I told you, in this video I explained similar type of fruits. Let us take mangoes, because that fruit is king of fruits, no? That's why I've taken mangoes. Mangoes, 10 mangoes are there, 10 mangoes are in one basket. And 10 mangoes are in one basket. We have to distribute, of course, to the 5 children. In how many ways we can distribute 5 children? The concept is explained like this. To one child, we can give 10 mangoes. In how many ways we have to understand? To one child, I don't give even one mango. To one child, that child only, I am taking only one child. I am taking one child. Let us take Gopi. Gopi is the name of that one child, suppose. To Gopi, I don't like to give even one mango. I may give one mango to Gopi. I may give 2 mangoes to Gopi. I may give 3 mangoes to Gopi. I may give 4 mangoes. So on, I may give 10 mangoes, all 10 mangoes to Gopi. These are the chances. To Gopi, all these 10 mangoes I can give like this. Like Gopi, how many children are there? 5 children are there. So here, x power 0 plus x power 1 plus x power 2 plus x power 3 plus x power 4 plus so on plus x power 10 whole to the power 5. So what is this multinomial expansion is? It is restricted to one kid Gopi. To Gopi, I may not give even one mango. To Gopi, 1 mango I can give. And to Gopi, 2 mangoes I can give. To Gopi, 3 mangoes I can give. 4 mangoes, 5 mangoes, 10 mangoes I can give. These are the chances I can give. As I wish, I can distribute. So this is the distribution to one Gopi child. Like this, 5 children are there, whole to the power 5. Like Gopi, another child may be Charan, another child may be Josh, another child may be another name with another name, we can power 5. This is called division of identical objects. Mangoes are identical, no. They are identical objects into groups. This is the concept built. This is the concept built on this illustration. What I have illustrated to you. With this notion, it is highly developed, and it will be with this notion, so many difficult questionnaires questionnaire are solved. So many difficult questionnaire are solved with this notion or by this notion. Simple notion. All great principles started from simple notions only. This is also simple notion, and this is more applicable in difficulty part and difficulty region of many mathematical questionnaire. That thing today in this video I discussed. This is how related to binomial theory. We have given here 10 mangoes to 5 children. How many ways we can distribute? It is nothing but the coefficient of x power 10. The coefficient of x power 10. In the expansion of x power 0, that is 1 plus x square, so on up to x power 10 whole to the power 5. It is exactly related to multinomial theory, exactly connected to coefficient of x power 10. You see here, one question I gave to you, total number of ways in which 30 mangoes can be distributed among 5 persons. 30 mangoes can be distributed among 5 persons. So, x power 0 plus x power 1, x power 2, so on, x power 30, because 30 mangoes. Like that, how many? To 5 children, so whole to the power 5. How many ways we can distribute? The ways is nothing but the coefficient of x power 30. So, combinatorics is involved with binomial theory and vice versa. These things are most useful in finding probability questions. So, in connection with this, I gave some probability questions discussed here. 3 dice are thrown together. 3 dice are thrown together. The probability that the sum of the numbers appearing on them is 9. Suppose the question may be like this. 3 dice are thrown means n of s is 6 cube. 6 cube, once we discuss this one. N of s is 6 cube. N of e is, total number appearing on them is 9. 3 dice are thrown together. The probability that the sum of the numbers appearing on the dice, on the faces, sum of the numbers is 9. So, exactly related to the binomial theory or multinomial theory, we will find coefficient of x power 9 in the expansion of dice, no, x power 1 plus x power 2, x power, that is x plus x square plus x cube plus x power 4 plus x power 6. Because 1 may be turning up, 2 may be turning up, 3 may be turning up, 6 may be turning up. One die may turn up like this. So how many days will be there? Or 3 days are there. So whole cube. So x plus x power 1 plus x square plus x cube plus so on, x power 6. What is x power 6? 6 number turns up. What is x power 5? 5 number turns up. 3, x power 3, 3 number turns up. Like that. How many days or how many times? Times may be given, days may be given. That will be whole cube. So, total how much? Must be 9. If must be 9, what is the probability? So, permutations and combinations, theory of that, involved with the binomial theory, we are telling exactly the coefficient of x power 9 in the multinomial expansion in x plus x square plus x cube plus x power 4 plus so on plus x power 5 plus x power 6 whole cube. That's all. So how to find the coefficient of x power 9? That you have to know and you have to learn. In binomial theory, how to find coefficient of x power 9 or x power 10, x power 6. For that, please go through this video. I have done in my book. I explained it. Totally, topic is this today. Today topic is only based on combinatorics, only the involvement of combinatorics and binomial theory in probability. Please go through this video. I have done some questions and explained them in this video in my book. And don't forget to subscribe and click bell icon so that you will get my updates. You will learn many things. In the next video, let us meet. Okay, bye. My dear students, these basics you must learn. You must follow these basics. Basics on combinatorics. NPR equals to NCR into R factorial. NPR equals to NCR into R factorial. NCR equals to NCN minus R. NCR equals to NCN minus R. For all 0 less than or equal to or less than or equal to n. Let n and r be non-negative integers such that r less than or equal to n. NCR plus NCR minus 1 equals to n plus 1 CR. NCR plus NCR minus 1 equals to n plus 1 CR. These things you are learned in combinatorics, that is in permutations and combinations. So these fundamentals and basics you must be aware of. Let n and r be non-negative integers such that 1 less than or equal to or less than or equal to n, then NCR equals to n by r into n minus 1 CR minus 1. If 1 less than or equal to or less than or equal to n, then n minus 1 CR minus 1. Same idea. N minus 1 CR minus 1 by NCR minus 1 equals to n minus r plus 1 by n. This and this you must remember. These you must remember in the topic of permutations and combinations. We will discuss these things in detail. But for probability, we have to apply these formulas. Next, NPR equals to n into n minus 1, n minus 2, so on, n minus r plus 1. NPR can be written like this or can be written like this or can be written like this. NPR equals to n factorial by n minus r factorial equals to P of nr. Some people they will write like this. Or NPR equals to n into n minus 1, n minus 2, so on, n minus r plus 1. NPR means, P means permutations, number of arrangements. Taken over at a time, arrangements in the number of n blanks, that is NPR. This can be written as in factorial ways, n factorial by n minus r factorial equals to P of n r. NPN equals to n factorial, but NCN equals to 1. Please observe this. NCN equals to 1, NPN equals to n factorial, NP0 1 and NC0 is also 1. If n is even, greatest value of NCR 0 less than or equal to or less than or equal to n is NCN by 2. If n is odd, the greatest value of NCR is NCN plus 1 by 2 or NCN minus 1 by 2. There are two values. Here is very, very important one concept. Division of identical objects into groups. Why I am telling all this about the combinatorics? Because these permutations and combinations, laws, principles, ideas will be applied in probability. And moreover, in connection with this division of identical objects into groups, in connection with this, binomial expansions, binomial series and binomial expansions will be happening to connect with this. So, some binomial quotations, some binomial values from some binomial results, fundamental results must be useful and they are applicable in the topic of probability. So you have to learn permutations, combinations and some binomial standard results. All these will help you to do probability sums. Actually, binomial theorem is a one particular topic. The topic is there. In that topic, especially you learn it. One topic is combinatorics. That topic is there. In that topic, especially you learn it. Even then, once I told, probability is very friendly with all these topics. With all these topics. What topics? Permutations and combinations are combinatorics, and binomial standard results, binomial expansions and series. Okay, and sets and relations, functions. All these topics are very, very close friends to probability. So we must, if you want to know about probability, you must know about probability friends. The friends of probability you must know first of all. Division of identical objects into groups. For that, I have given one best example. Even a small kid can also understand. The king fruit of all fruits is mango. I have taken mangoes. All mangoes are similar? No. Of course, sizes may be different and the type may be different, but mangoes, all mangoes, no. Mangoes, 30 mangoes are there, 30 mangoes are in one basket. Please observe my question. So, how many ways we can distribute these 30 mangoes among 5 persons? In this question, how do we do in combinatorics? So that is the another way, total number of ways in which 30 mangoes can be distributed among 5 persons. How to distribute, you see. I will explain like this. So we are entering into binomial expansions for doing this question. Why we are going to learn this question? If you know the idea of this question, how to do, you can easily understand the idea of the questions given in probability. That is why at first I am discussing this. Okay, now come to the point. Here 30 mangoes are there. How many persons? 30 mangoes are there. How many persons are there? How many persons? 5 persons are there. Okay. To first person. This is first person. This is first person. I am focusing very clearly. This is first person only. First person, I don't give any mango. 0. I will give 1 mango. I may give 2 mangoes. I may give 3 mangoes. I may give 5 mangoes. I may give 30 mangoes. This is only 1 person to 1 person. To 1 person, 30 mangoes can be given in how many chances? To this 1 person, this is 1 person only. To this 1 person, I may not give any mango, 0. I may give 1 mango. I may give 2 mangoes. I may give 3 mangoes. I may give 10 mangoes. I may give 30 mangoes. Like that, x power 0 plus x power 1 plus x square, x cube, x power 10, x 20, x power 21, 20, like that, x power 30. This is regarding one person. Try to understand. 30 mangoes to one person. You may not give even a single mango. You may give one mango. You may give 2 mangoes. You may give 3 mangoes. You may give 30 mangoes. That is the chance I am telling. To the first person. 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 To the second person, same. To the second person, same. I don't give, I may not give, I may not give, I may give one, like that, second person. Third person, fourth person, 5 persons. So how many brackets? 5 brackets. 5 brackets means 5 persons I keep like this. Thus, the required number of ways of distribution among 5 persons converted into binomial coefficient concept. Excellent way of logical turning. It is a logical turning, telling chances in combinatorics and suddenly turning to binomial coefficient. It is nothing but required number of ways of distribution among 5 persons of 30 mangoes is nothing but coefficient of x power 30 in 1 plus x plus y 1 plus, because that is x power 0 1 x square x power 30 whole power 5, because 5 times I have kept, 5 times I have kept, no, so whole power 5. Now this is coefficient of x power 30 in 1 plus x square, so on, plus x power 30 whole power 5 can give us the required number of ways of distribution among 5 persons. Excellent, no? Mixture of concepts of binomial and multinomial expansions. Now we are going to change in binomial. Coefficient of x power 30 in 1 minus x power 31 by 1 minus x. This can be written as like this, 1 minus x power 31 by 1 minus x whole power 5. So this is nothing but 1 minus x power 31 whole power 5, 1 minus x whole power minus 5. Which coefficient we want? We want a coefficient of x power 30 in 1 minus x whole power minus 5, because here 1 minus x power 31 is there, no? How do we find from this x power 30 quotient? Not possible, no. That is why I have left this part. I have taken only this. So, coefficient of x power 30 into 1 minus x whole power minus 5. The formula in binomial expansions is, since coefficient of x power n in 1 minus x whole to the power minus r equals to n plus r minus 1 cr minus 1. Constantly I am keeping for 2 seconds, because the formula you have to remember. Coefficient of x power n in 1 minus x whole power minus r equals n plus r minus 1 cr minus 1. Same way, 30 plus 5 minus 1 c5 minus 1 equal 34 c4. That is 34 c4. So how total number of ways in which 30 mangoes can be distributed among 5 persons is 34C4. In how many ways, same question, can 20 identical toys, mangoes I told, now 20 identical toys, both are same now, be distributed among 4 children so that each one gets at least 3 toys. Here a small logic, such that each one gets at least 3 toys. So CFT of X power 20 in at least 3 toys means 3 toys, 4 toys, 5 toys, up to 20 toys. How many children? 4 children. So like this, 1 child, first child, you see, first child, at least 3 toys, first child, 3 toys may be given, 4 toys may be given, 5 toys may be given, like that 20 toys may be given. These are the chances to first kid, first child. Like this, how many children will be there? Like this, 4 children, so power 4. Just previously how mangoes question we have done, like that only. So coefficient of X power 20, we want X power 20 because how many ways can 20 identical, so CFT of X power 20. In previous question, 30 mangoes, X power 30 coefficient we have found, no. Similarly, we have found this CFT of X power 20 in like this. How many children? 4 children. Each child, at least 3 toys, What is the question? At least 3 toys. It means 3, 4, from 3 only you have to start. Now, the logic is, X cube is there now? X cube. You please take X cube out. X cube, this is power 4, X power 12, you take out. If you take X power 12, and now coefficient of X power 8, because this is 20 and this is 12, so 20 minus 12, 8, you have to subtract. 20 minus 12, X cube if you take X cube power 4, X power 12, so X power 12 if you take X power 20 minus X power 12, X power 8 will be coming. Suppose downwards will be there, then X power 12 and 12 plus 20, 32, X power 32 coefficient you have to find. Down. If it is not down, in this place only, in numerator place only, X cube power 4, X cube if you take common, what will be remaining here? 1 X square, X power 17 like that. Because X cube you have taken power 4. And as X cube you have taken X cube into 4, X power 12. What I said now, X power 20 minus X power 12. 20 minus 12, sorry. 20 minus 12, how much? X power 8 coefficient you have to find. So, X power 8 coefficient you have to find in 1 plus X square plus so on plus X power 17 whole power 4. That is, according to this 1 minus X power 17, no, X power 18 by 1 minus X whole power 4. So, X power 8 coefficient, how do we find? Can we find in X power 8 coefficient in X power 18? No. That is why I did not take that one. CFT of X power 8 in 1 minus X whole power minus 4. The formula is just I told n plus r minus 1 c r minus 1 8 plus 4 minus 1 c 4 minus 1 11 c3. So 11 c3 is the answer. 11 c3 ways we can distribute 20 identical toys among 4 children so that each one gets at least 3 toys. That is why I started from 3 like that. And come to the point here, some important expansions in binomial theory. Some important expansions. You observe 4 important expansions are given. 1 plus x whole power minus 1. Infinity expansions these are. Infinity. 1 minus x plus x square minus x cube plus x power 4 plus so on plus minus 1 power or x power or plus so on up to infinity. Next, 1 minus x whole power minus 1. 1 plus x square plus x cube plus so on plus x power r plus so on plus up to infinity. And next, 1 plus x whole power minus 2. 1 minus 2x plus 3x square minus 4x cube plus 5x power 4 so on plus minus 1 power r plus 1 x power r plus so on infinity. And now 1 minus x whole power minus 2. 1 plus 2x plus 3x square plus so on. Like this plus r plus 1 x power r plus so on up to infinity. Like this 1 plus x whole power minus 3. 1 minus 3x plus 6x square minus 10x cube minus 1 power r plus 1 r plus 2 by 2 x power r plus so on up to infinity. And next 1 minus x whole power minus 3. 1 plus 3x plus 6x square plus so on plus r plus 1 r plus 2 by 2 x power r plus infinity. Like this. Some important expansions infinity expansions from binomial theorem. These are very important for the applications while doing probability questions. Applications of combinatorics and binomial theory in probability. In probability, you must have been known to binomial theory, some binomial theory, not some, very important points of binomial theory and very important points of combinatorics. So, applications of combinatorics and the binomial theory in probability. Let us start our question. 4 tickers are marked 0, 0, 0, 1, 1, 0, 1, 1 respectively. 4 tickets are marked. On the tickers, the marking is 0, 0 numbering 0, 1, 1, 0, 1, 1. Are placed in a bag. A ticket is drawn at random 5 times. A ticket is drawn at random 5 times, being replaced each time. Each time. The probability that the sum of the numbers on the 5 tickets drawn is 24. Carefully listen. 4 tickets numbered as 0, 0, 0, 1, 1, 0, 1, 1. They are placed in one bag. 4 tickets are placed in one bag. All the 4 tickets are in one bag. A ticket is drawn at random 5 times. A ticket is drawn at random 5 times, being replaced each time, taking the ticket and again dropping in the bag, being replaced each time. The probability that while you are taking like that 5 times, then the sum of those 5 numbers is 24. Such a way, if 24 comes or if 24 turns to come up as the sum of these 5 tickets, then what is the probability? That is the question. So in these cases, we have to use the idea of distribution. Identical items, 30 mangoes distributed among 5 students, 5 children. That I told first, no, you have to know about it. And I start to know that one, and we are just slipping into binomial theory, no. That you have to remember. Now, what is N of S? N of S is number of ways drawing 4 tickets. This N of S also for some students may be difficult. Because I am telling N of S how. You kept your hand, you keep your hand in your bag, and you take 1 ticket. The ticket may be 00 marked, or maybe 01 marked, or maybe 10 marked, or maybe 11 marked. There are 4 chances, either 00 marked or 01 marked or 10 marked or 11 marked ticket you can take out and see the number, and again you drop in the bag. That is replaced. Like that you are taking 5 times. So when you keep your hand in your bag and take out 1 ticket, maybe 00 marked, 01 marked, 10 marked, 11 marked. How many chances will be there? 4 chances. So that is 4. This is keeping your hand in bag 1 time, 4 chances. 5 times, 1, 2, 3, 4, 5 times, 4 power 5. This you have to understand very clearly. Number of ways drawing 4 tickets. N of S. Now N of E. N of E is total should be 24. So CFT. CFT means what? Coefficient of export 24 in. You see 00 coded, 01 coded, 10 coded, 11 coded. By these numbers only, no, you are getting 24. So, how many times? 5 times, whole power 5. So, you must be able to frame one binomial, not binomial, multinomial expansion. And you have to change this into binomial expansion later. So CFT of export. CFT means coefficient of export 24. Coefficient of export 24. Same model you all learned in combinatorics. Just before this question I told. CFT of export 24 in like this. So what are the factors? Like these factors. So what is this? 1 plus x whole power 5. And the binomial expansions. I changed this 4 nomial as a binomial product. So you have to learn the expansion. Once I told 1 plus x whole power n. Please observe. 1 plus x whole power n. nc naught plus nc1 dx plus nc2 into x square plus so on plus nc r in x power r plus so on nc n x power n. Previously also I told. Before video, in the prior videos you learned it. Same way I have written like this. Up to this only I have cleverly written, because why do I write all? Because I want only x power 24 coefficient 24 coefficient in this. If I write like this, 20 is here. 20 is here, no. Now, what is how to find x power 24? 5c2 into coefficient of x power 4 in 1 plus x power 5. How? Because x power 20 is there. 5c2 x power 20, 5c2 x power 20 into 1 plus x whole power 5. Observe. 5c2 x power 20 into 1 plus x whole power 5. I have taken this one, and this one. If you take this one, x power 20 came, no. So x power 20, if it has come, here what is the coefficient x power 24? No. Before this I told x power 24, 20 x power 20 comes and x power 4 only. You have to minus it. So 5c2 into coefficient of x power 4, because this is 24 and this is 20, x power 20, so x power 4 only, 24 minus 20, x power 4 coefficient only in 1 plus x whole power 5. Now we write 5c2 into coefficient of x power 4 in 1 plus x whole power 5. How it is possible? You know that 5c2 into 5c4. Why? What is coefficient of x power 4? You observe the expansion of this. X square coefficient NC2, x power r coefficient NCR. Okay. By this formula, by this expansion, you can tell what is that? What is that? 5 x power 4 coefficient is 5c4. 5c2 into 5c4. 5c4 can be written as 5c1 because I have given one formulas first in this video, today's video. I have told you NCR equals to NCR minus 1, 5 minus 4, that is 1. 5c4, 5c1 both are same. So 5c2, 5c1. 5c2 is 5 into 4 by 2, already I told, into 5, that is 50. This is N of E. So here P of E equals to 50 by 4 power 5, 25 by 512. Six faces of a die are marked with the numbers 1, minus 1, 0, minus 2, 2 and 3. 1, 2, 3, 4, 5, 6 faces of a die. It is not a regular die. It is not a fade die. The die is thrown thrice. The probability that the sum of numbers thrown 6. Okay. So N of S equals to die is 6, no, 6 faces, no. How many times thrown thrice? So 6 cube. N of E equals to coefficient of x power 6, because sum of the numbers thrown, how much? 6. So as you learned, as you followed previous question only, x power 6, coefficient of x power 6 in. How It is marked with the numbers 1, -1, 0, -2, 2, and 3. Observe. 1, -1, 0, -2, 2, last 3. Die is thrown how many times? 3 times, thrice. So power cube, thrice. Cube means thrice. So if we simplify this, x plus 1 by x plus 1 plus 1 by x square plus x square plus x cube. If you take LCM, x square will be coming. So 1 plus x square plus x cube plus x power 4 plus x power 5 whole by x square whole cube. Just before this I told, this is x power 6. If you take outside, x power 6. X power 6 and this one x power 6 coefficient. So x power 12 coefficient you have to find. Because once I told, downwards if you take you have to add, upwards if you take you have to subtract. Before this question subtracted, now you have added. So x power 6 plus 6, x power 12 coefficient you have to find. That is CFT of coefficient of x power 12 in 1 plus x plus. Coefficient of x power 12 in 1 plus x square plus x cube plus x power 4 plus x power 5 whole cube. CFT of x power 12 in, you write in binomial form. This is multinomial, you have to change this into binomial. X power 6, 1 minus x power 6 by 1 minus x whole cube. So 1 minus x whole cube into 1 minus x whole power minus 3. Now you are turning into the results of binomial expansions. CFT of x power 12 in, coefficient of x power 12 in, whole cube, 1 minus x power 6 whole cube, 1 minus 3 x power 6. This is formula, you know, a minus b whole cube. A cube minus b cube minus 3a square b plus 3ab square. And 1 minus x whole power minus 3. Now, CFT of x power 12, 1 minus x minus power minus 3 into 1, this one. Minus 3 into 1 minus x power minus 3, this one. But here what is there? X power 6 is there. What is this? X power 12. So x power 6. 12 minus 6, x power 6 coefficient. Okay. Next. Plus 3 CFT of x power 12. X power 12 coefficient only. So 12 minus 12, how much? X power 0 coefficient in 1 minus x whole power minus 3. Now you write 12 coefficient 12 x power 12. 12 plus 3 minus 1 c 3 minus 1 n plus r minus 1 c r minus 1. Formula I told now before. Minus 3 into 6 plus 3 minus 1 c 3 minus 1 plus x power 0. 0 3 minus 1 c 3 minus 1. That is 3. We got the answer 10. That is 10. P of E equals to 10 n of E by 6 cube. Simplify and we got 5 by 108. 5 by 108. 6 faces of a die are marked with the numbers. The die is thrown thrice. The probability that the sum of the numbers thrown 6 is 5 by 108.